heat, sir?
Yes, it is the resistance is a dissipating device. It is going to dissipate heat. So some amount of power is going to be lost in the form of heat. But for that, I cannot go for L and C, right? Because the linearity is going to be lost. So I am okay with the amount of energy lost due to heat, but still I use only resistors and power supply for constructing my biasing circuit. Okay, so the circuit which is going to be used for getting the desired operating point is called as biasing circuit, and we have seen the collector current across the common emitter amplifier is given by this equation. IC is equal to beta into IB plus this current. This additional current is going to be your reverse saturation current. In common emitter amplifier, you call the current as ICE naught. In common base, you call it as ICB naught. Okay, since we are more bothered about common emitter amplifier, so with the normal current IC equal to beta into IB, you also have the reverse saturation current coming into picture. And this IC E naught is related to IC naught by this formula, 1 plus beta into IC naught. So I am not going to derive how the relation is going to be. This relation we have studied in devices. So the IC E naught, the reverse leakage current of a common emitter transistor, is related to the current IC naught, the reverse saturation current of an actual transistor by this formula, 1 plus beta times IC naught. So you can see here the three variables which are going to influence the functioning of BJT is going to be, one is beta. Beta is going to be the current gain. One is going to be IB, the base current, and another one is going to be IC naught. IC naught is the reverse saturation current. So I have told you in the previous thing, it is VBE. So VBE will actually influence your IB. Okay, VBE will influence your IB. Okay, so the three parameters which are, and you see in the above equation, all the parameters which are depending on temperature is coming in a single equation. So I can say the dependence on temperature is going to be because of these three parameters: beta, VBE. Instead of VBE, we can put IB also, because VBE will determine the amount of base current flowing, and IC naught is the reverse saturation current. So these three parameters are going to increase with temperature. They are not going to decrease. They are going to increase with temperature. So when the temperature is going to increase, these parameters will increase. If these parameters are increasing, then your Q point will change. So if Q point is going to change, the transistor will no longer work as a proper amplifier. So you have to be very, very careful in maintaining the operating region or operating point of your bipolar junction transistor. So see here, for every 10-degree rise in temperature, IC naught doubles itself. See, IC naught is a reverse saturation current. It will be in the order of microamperes only. But if the temperature is increasing, the small microampere current will become milliampere current. That when you add already with existing milliampere current, that is going to disturb the functioning of your device. So active region is going to be completely disturbed because of this temperature dependence. So when IC naught is going to increase, IC will increase. When IC is going to increase, the power dissipation will be very, very large. So which will even break down your transistor. So transistor is designed for a particular amount of current, collector current only. If that collector current is going beyond a particular value, then you cannot expect the device to work as an amplifier. The device will start functioning in an absurd manner.